here's all the, you know how we had all those attributes on the fluid chamber that we made? This is the nParticles, right? All kinds of stuff.
No, it's all the same stuff that's in the attribute editor, correct?
Kind of, yeah.
It's just some are different.
It's just some are in a different spot. So if I render this, this is what I get. Like little beads, right? Just blobby particles. So I can zoom in on this. Looks like nerds candy. Isn't that like blueberry nerds?
Oh yeah.
Yeah, kind of.
Delicious.
Yeah,
So we've got a lot of different things here. We've got thickness, we can change that. So it's 0.1 by default. I changed it to 0.5. May not see too much of it actually. Yeah. On with the nParticle selected. So you've got bounce, which will let the particles bounce off something. So right now the bounce is set to 0, right? So they hit the bowl and they just kind of go in the bowl. But if I take this and I change this bounce, if I change this bounce to like 5, watch what happens now. I actually change it. So now the particles are coming out, and they're going to bounce like crazy when they hit the stuff.
whoa.
You might start to freak out. Yeah. This stuff is super buggy, so save often. So that's that. Stickiness, I can crank that up a little bit. Let's see what that looks like. If I change this to like 0.5. So now it's going to behave more like batter or something. So it's going to want to stick to a surface when it pours. So it'll like slide over itself, but when it hits an object, it's going to want to stick to it. So this is what that looks like. No, I'm just butt busting. Or not even butt busting. So it's kind of like oozing down the side walls of the cup. It's kind of gross. So that's stickiness.
Can you change the stickiness of the material?
Yes. You mean of the cup and bowl?
Yeah.
Yeah. Let me change that stickiness back to 0. Oh, yeah, let me do that. Let me change the stickiness to 0.8 and I'll play lost out. So this would be useful if you're doing like blood with like some kind of ooze. For video games, you're gonna have to do blood a lot, or slime, or oil, or mud, or landslide kind of thing. Alien guts. The way we did it here, we automatically filled that cup with particles. If we made a particle emitter, yeah, you can tell how many particles. Well, for that, there's a couple different ways you can do it. You could have fluid, and then inside there like a little pocket of ketchup kind of, and then cut it and let it fall out. So that's with a pretty high stickiness value. So you see it kind of wants to stick to the edge of the cup, and then when it goes into the bowl, it wants to stick kind of where it hit. You don't get that big sloshing around effect that we did before. Yeah, so this is a little more solid. So if you were going to simulate maybe like grains of sand or dirt or something, maybe you want to have a little bit higher stickiness so that it doesn't flow all over the place, but it actually kind of hits and stays. Yeah.
Have you ever seen that movie? This is what interested me in the whole thing. Have you ever seen the movie Frighteners? With how they when he slaps.
I haven't seen it long. That's one with the numbers part.
Yeah,
right?
And then like he catches the.
Michael J. Fox.
Yeah.
Yeah.
I remember that. He's like it's like plasma or like goo, and he's just hitting it. And
Yeah.
is that what they used Maya for that? Or?
No, that was way before it was. I remember that. It was Peter Jackson. He's actually in that movie. He's like standing on the street or something.
No,
Like that thing.
I
Around both of the guys like a biker or something.
He's in all his movies.
Okay, so we've got stickiness. We talked about bounce a little bit. Let me change this back to real stickiness.
So if we were trying to get the effect of water.
Right. Viscosity. This is where viscosity is how viscous, how fluid and motion the liquid is. So something like toothpaste is highly viscous, right? You can squeeze the tube and it's liquid and it comes out, but it moves really slow, yeah?
Now, is that like an actual scientific
Number?
measurement? Like, could you Google the
It's close to it.
viscosity of toothpaste or
Yeah,
something
Maya
like that?
tries to do that. It's not like refraction where it's like a very set
Right.
number. Like refraction, you can look that up.
Right.
The water is like 1.33, so if you're gonna do a shader, you can use mental rays.
Right,
Figure out
it's
all
not
that
like
stuff.
that.
Viscosity is a little bit different. But so 0.1 viscosity. I'll just leave. We already rendered this one viscosity at 0.1. If I change this viscosity to like 0.8, I turned off the stickiness already. Let me play blast this at 0.8. So I'll just call this high and just play blast that. So this will be more like pancake batter or something like that. You see how it doesn't want to splash around, it wants to kind of stick together?
Mhm.
Yeah.
Whoa. That's cool.
Need sound effects.
Oh, one piece fell out.
Later, guys.
It's a social binder. Okay, I'm glad that happened because you'll see what happens here. So watch when this hits. There's no friction on the bowl or the ground. So when this hits,
It's gone.
it just slides like crazy. It's like oil on glass or something, right? It just goes.
Yeah.
So what we need to do to fix that, because you wouldn't want that, that'd be so distracting in a movie. Like you get this big epic murder scene, the blood flies out, and this one piece like, everyone would laugh at your stupid movie, right? So how do you fix that? We need to add friction to the objects, not to the fluid, but to the objects. So what I can do is, let me back this up. Select my object here. If I click on the rigid shape 2 node, right? So on each of these things, right, the cup, the bowl, and the ground, we've got underneath we've got this outputs section that says rigid shape 2. That's the actual end mesh thing that we made, right? So when we made that an end mesh, it added that end rigid shape node to it. So if we click on that, I made this on myself, you can specify different things. So let me talk about what they are a little bit before you do anything. So thickness, that's how thick this object is. So if you're doing very detailed, like your camera's real tight on something, you've got a really intricately modeled piece of geometry, you want your thickness to be pretty low because it's got to be very close to that geometry. If I crank this thickness up, think of it as like an invisible force field that gets larger around that geometry, right? So the thicker this thickness value is, the higher it is, the more space there's going to be between where the actual collision happens and the geometry itself. So the default is pretty low. That works for a lot of mainstream things, right? But you may need to go in and adjust this. Bounce, we already talked about what that does. Friction, right now it's set to 0.1 by default. So that when it hits, it's a little bit frictiony. You can crank that up a little more. Stickiness, that's how sticky it is. We talked about that with the fluid. Plus it works kind of the same way on that. And then there's a lot of other things too that have to do more with simulation works. Like collision flag face, you can change that to like vertex instead. Self-collision flag, so if this thing moved, it could collide with itself based on the vertex. It's kind of techy, a little bit outside the scope of what we're talking about.
So the same controls would be referred to this cup if you wanted to be.
Yep. So what I'm going to do is on this bowl, I'm going to add a little bit of friction, 0.5 for the friction. And for the ground, I'm gonna crank up the friction value. So I'm gonna select this shape here, and I'm going to change this friction to 0.8.
Was friction visible?
I did 0.8. And these numbers I'm just kind of pulling out of my butt. It has no real correspondence to anything. I'm just kind of seeing what it looks like.
And the cup is 0.8?
No, the ground's on it. I just ran in on the cup. So we may not even get that little piece that shoots out this time because I put some friction on the bowl. But let's see what this looks like. So you just ask what would happen if we added friction to the cup. It would still come out, but it wouldn't come out as fast. Because right now I have no friction on the cup. Actually, there is friction. It's like 0.1. So it's very low. So I just wanted to kind of come out of there quick. So you would use this for different materials. So like if you're pouring water, or like let's say you've got, well, if I took water right now and I went like this across the floor in here, the carpeting would kind of catch a lot of that water. So in the computer, the friction value on the carpet would be pretty high. So if I took it and I splashed it against the window, right, they would get really mad at me. But also, it's very low friction on the glass, right? So it would just hit, kind of deflect. It might stick a little bit. It might crank up stickiness value, so I get like a film over it. But it wouldn't really do too much. It looks like the friction really changed the way that behaves in the bowl.
Looks nice.
Like wet cement. But you can see what the differences are, right? I mean, it's the difference between like entry-level fluid stuff, like I just push this button to make fluid, and now you're actually artistically adjusting the simulation so that you get more of a result of what you want. And it's kind of cool. You can start to see like when you get like little surges in the pressure, like you'll see the stream start to change a little bit as the fluid like hits inside the cup and splashes out more. The stream gets a little wider or narrower based on what's happening in there. Fluid simulation is where you see a lot of people using helper shapes and things. So in a movie where there's like a flood, anybody ever see the movie with Christian Slater, where there's like a flood in town, like Tommy Lee Jones is in the town, there's like it's like Hard Brain.
Hard Brain, that's it, yeah.
And like there's a flood in the town and they decide they're gonna knock off this bank, I think, or something like that. And it's during this huge flood, so the town's evacuated. And they keep showing all these floods. Well, that movie, they shot that all practically. And they used like big dumpsters, and they filled like garbage dumpsters full of water, and they were just off frame a little bit. So the camera's here, the dumpster's here, they're like, action! And they got a bulldozer or something that just dumps this thing of water down into the street. And they're like, oh no, the flood, and they get swept away or whatever, right? You can do that with this. You know, if you're doing a shot, let's say you're doing a film of, well, let's say you're doing like a more realistic thing. Let's say you're trying to do something about like the tsunami, right? You could totally frame your shot, just build a cube next to it with a little trap door, fill it with fluid, and then when you want the water to hit, pull the door away, and all the fluid will fall out, right? Or you can make a big ramp, make a shape that has like a big ramp at the end of it, and put a particle emitter here that shoots the particles straight, and then when they hit that ramp, they'll fly up in the air. You can use that to kind of shape your splashes and everything too, so you can get really cool effects. So what I'm doing here is I'm using, this is like a real cup shape, so the stream looks like a real cup. But if I use an emitter, you get this really computery, like I am putting particles in the scene, like everything is
It's like
uniform and like, you know, robotic looking. Yeah, you wanna kind of put more of an artistic feel to it, right? So if you're gonna have, even if you don't see what the water's pouring out of, you want to try to make it more realistic and put like actually model like a picture, like a front of a picture, like the spout would
Like
pour
that
out.
would be like this.
So like here's your handle, here's your spout, right? You want to model that so that the result is something that looks like what you want. So if you're doing a Kool-Aid commercial, you want the Kool-Aid to look as real as possible. You don't want it to look like blood or mud or something like that. That'd be horrific.
What else is inside?
Oh yeah, it comes in, he's full of blood for Halloween. It's new Halloween Kool-Aid. It's gross. But so you want to think about what your end result is. So what we want to do for next week is this. I'm gonna have a cup that pours into a bowl, and the liquid looks realistic. And this is what you need to handle, something like this. A flame blast, and I want to see that you actually did like some friction to the bowl and some stuff to the cup and thought about how the liquid's going to look. It's up to you what kind of liquid you do. I've had people do like cement, so it's like real thick, so they pour it out the cup and just like, and like plops into the, it's so disgusting, it just like plops into the bowl. But it looks kind of cool. Sometimes you get a little bit of splash out of it too. So that's what we want for next week, right? I'm also going to show you like old school, non-fluid related way to do dripping liquid, which is really tough to do. So like you've got a candle that you've modeled, right? And and you want to have just like a little bit of wax run down the side of it, or you did a commercial about litter, and you have an Indian and you want to have one tear.
Oh.
Yeah. Okay. Those are popular.
Are we gonna put meshes on those or no?
I'm going to show you how to do that, but I guarantee it will crash mine. But I'll show you how to do it anyway. I would advise you not to try it because it's going to crash. And save your file if you decide to do it, and it may even corrupt your file that you saved. So save it as something else.
So for next week, you just want pretty much just like that plate left.
Yeah, and make sure you can see your particles. So well, you all have this file right now, but make sure you can see the particles. If you want to take this shader and make it even lighter, so that you can actually see the particles. So you can see what's going on. Okay, so the question came up, how do you make this look like real water? Well, buy RealFlow. And if you can't, then you're stuck with what you got. So what we're going to do is we're going to use my blobby particles to kind of paint liquid with this. Blobby particles. So I'm going to select my particles here, right? And I'm going to go into my attribute editor. And I've got particle size. I can crank up the radius here.
Whoa.
Whoa.
That looks like something else.
Wait.
You're gross. Alright, so I'm going to just
I'm not
crank this up a little bit.
seeing it.
You select the part.
You have your particle selected,
Yeah.
and in your attribute editor you have particle size.
Under what tab is that under? Oh,
Select my
there,
particles.
there.
Liquid simulation. We've enabled liquid simulation. Incompressibility, that's how much the particles want to compress. Rest density, that's how dense they are when they're not moving. Liquid radius scale, that's to do with how the liquid is in relation to one another, the particles. And viscosity, this setting comes from what we set on the particles in the other spot.
That's fun.
Particle size.
You should see it when it first.
So if I render this, this is what I get.
In the air.
A little more.
Like super slow.
So in order to make this look like liquid, you got to kind of know a little bit about rendering. Bum, bum, bum. So I'm going to go to mental ray, right? Change my quality. Matt Baker's not in here, is he?
Oh, dear God.
He always yells at me every time I use mental ray to like, you should set the setting to like 0.6, blah, blah, blah. And I'm like, I'm just showing them quick. Alright, so he's a good guy, he just isn't really into it, which is good. He's going to go far. But anyway, yes. You know, you don't have to render yours for next week. I'm just showing you how you would do it if you want. So that's what I've got. That's the default shader on here. I want to make this look way better than it does. So what I can do, yes, I'm going to go into my pepper shade. And I'm going to make a new material. So metal ray materials, I'm going to do this dielectric material, right? And this is the dielectric material here. I'm going to say ignore normals. I'm going to crank this coefficient up to something crazy, so I get a sharp speck highlight on there. And index of refraction, that's how much it refracts. So water has an index of 1.33, I think it is. I'm just going to put that in there. And then I'm going to take my particles here and apply that to the particles. Assign them. When I render this now, this is what I get. Which doesn't look that impressive, but I don't have any lights or shadows in there yet or anything to refract from. So what I can do is I'm going to zoom out here. I'm going to create a material with a texture in it so that I can have something to refract. We'll do old school computer graphics. But that's why they can check voice. And I'm also going to add a couple of lights. Let's see. Direction, cast shadows. Just play last.
So is it possible to keep the water from like squishing down when you?
Yeah, that's that incompressibility.
Oh, I missed that. Okay.
But it's a little bit shady. It's not a lighting joke. It gets a little buggy. It doesn't always want to work right. Use ray trace sharp. I hate working at this resolution, but if I don't, I can't make the projector work. Forgive the tiny screen. No, it's about that. So it's starting to look more like something.
That's kind of cool.
Kind of looks like slimy, like hair gel or something. It doesn't really look like
Purple lights.
But you can see there, it's refracting the background, right? This same shader on a RealFlow mesh with the commands. But the way that Maya does particles, does liquid, you're stuck with these like marble shapes that don't deform. So you need a huge particle count so that you get tiny particles so you get better resolution than machine buys. So the current version that we have, the current version of Maya, sucks for doing that.
Now, why is that different for RealFlow?
Well, because what RealFlow does, RealFlow is its own package. It doesn't work within Maya.
Okay.
So if I was going to do this in RealFlow, I would animate the cup and the bowl, which I already did. And I would take those and I would export them and get them out of Maya. Then I go into RealFlow and import them. Now I have that motion. I can fill it with liquid in RealFlow. I can crank up the particle count in RealFlow because it behaves differently.
I was gonna say, just why is it able to handle more particles than Maya?
Just because that's how it works. The way that the particles in RealFlow work is the particles are points in space, whereas this version of nParticles, it's like a mesh shape that's meshing like a metaball would with another shape. So when the two spheres get close together, they kind of merge.
Right.
You know what I mean?
Yeah.
That's how Maya handles it. RealFlow kind of handles it that way, but it's separate from the particle system. The particle system in RealFlow is like points in space. You can crank up the density; they'll get closer or farther away. And then the mesh that creates your liquid happens as a secondary step, where you have control over the shape of the mesh too, so you can crank up the facets on the mesh, so that you get a better fit for your particles. It's hard to explain without having RealFlow to show.
Now, would you be able to create separate shapes within RealFlow to direct it, or you'd have
Yes.
to do it in Maya, export it?
Nope, you can do the shapes in RealFlow. You can't really model in RealFlow. So
Right.
you can do primitives, like you can do a cube, you can do a sphere, or a plane. But for particle simulation, for liquid simulation, that's all you really need is primitives, just something to splash against or something like that. It isn't until you do more complicated things like those horses and stuff that are made out of chocolate. You animate the horse in Maya, right? And then in RealFlow, fill the horse geometry with chocolate. And then you just don't render the horse geometry. You just let the stuff be liquid. Did anybody come to the workshop that I did like a couple quarters back? I did a RealFlow one. And we made a squirrel that was made out of chocolate. I had the squirrel animated already, and I just filled it with chocolate. And it worked exactly like the horses. It works awesome. It's excluded by RealFlow. So you can download a student trial. It's good for like 90 days or something. And there's other ways to get copies, I guess, but you can't install on school machines.
Now, does it do smokes and that sort of stuff, or is it just
It
basic?
does all kinds of fluid simulation, so that includes gases.
If we wanted